All right, guys, here we're going to start talking about combinations of atoms. So we're going to start with molecules. This is two or more nonmetals. All right. Now, metalloids can be part of this. All right. But I probably should have wrote not metals. All right. And these, they are held together. Like the atoms are held together by covalent bonds. All right. Now we're going to get to covalent bonds later, but right now we're just kind of defining our parameters. So they're held together by covalent bonds. Diatomic molecules, di means two, so this is two atoms. All right, so here we have two atoms. There are quite a few of these actually, and there are 7 elements that come as diatomic molecules. All right, 7 elements. There we go. And those elements, I use this as the sort of acronym Hofbrinkel. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine all come as twos. All right, that's just what they do. But you could have 2 different elements. So you could so we can have HBr or something like that. Oh, that was bad. HBr. All right. So they can be 2 different ones as well. All right. Now polyatomic molecules, these have contain more than 2. Contain more than 2. All right. I'm going to write some examples right here. Some examples of these would be O3, that's ozone. H2O, you guys are familiar with that. This is glucose, C6H12O6. So those are 3 examples of very, very many. There's a lot of them. Okay. And so here are 7 elements that are diatomic. Now, as we move on to ions, we're going to get into a little bit of a different scenario. Let's move this up a little bit. There we go. Ions. Okay. So ions, this is an atom, right? Or group of atoms that has gained or lost electrons. Gained, I'm going to just use a slash here, lost, and we're going to use our symbol for electrons. All right. So it's an atom or a group of atoms that has gained or lost electrons. All right. And what they're going to have is a positive or negative charge. Okay. So we get a positive or negative charge on these because they've gained or lost an electron. And what things are trying to do, so for main group, I'm not going to really write this down, it's going to be a ton, but for main group elements, they're all trying to have the same number of electrons as a noble gas. That's where everybody's trying to get. All right. And so first we'll do cation here. All right. These are, and I'm not going to write out the whole word, these are positive ions. All right. There you go. Positive ions. And in order to be a positive, you have to lose a negative. And so cations lose electrons. Okay. And so here's our little example. So potassium right here, we're not concerned with neutrons right now. These have 19 protons and 19 electrons. But what potassium does is it'll lose an electron. So it still has 19 protons because it's potassium, but it will have 18 electrons. And you can see that we have, for positive and negative, there are different numbers of each. And so this is a positive 1 ion because there's one more positive than negative. Now, anions here, conversely, they're negative ions. All right. So here, these gain electrons. All right. So for bromine here, bromine's got 35 protons and 35 electrons. But when bromine becomes an ion, well, it still has 35 protons because it's bromine, but now it has 36 electrons. And you could see on this periodic table, bromine's over here, Potassium's over here. And this has to do with the difference between metals and nonmetals. Nonmetals become negative, or they gain electrons. Metals become positive, or they lose electrons. Okay? And so with our main group elements, this is something that is going to be, you're going to have to kind of get used to doing this. Here, main group, they want same number of electrons as noble gas. All right, that's what they're trying to do. And so you could see in this chart here, sulfur's -2. It gained 2 electrons to be like argon, have the same number. Fluorine is -1 like neon. And you can see that these trends here for the main group elements, this charge is the same for everything in the group. So all the halogens make -1 ions. All this group 16 make -2. All group 15 make -3. All right. We're not going to really handle carbon, so don't really get too caught up in that. Group 1 here, all of these will lose 1 electron. Group 2 will lose 2 electrons. These are main group elements. The transition elements work under a different notion, and we'll get there later. All right. So just understand that these are going to work under a different set of rules. Okay. And lastly, for ionic compound, an ionic compound, this is a combo of cations and anions. Okay? And why might this be? Well, let's think about positive and negative attraction. Okay? I am going to make this very simple. An ionic compound is a metal plus nonmetal, or it is a metal plus polyatomic ion. And we'll get to those later, all right? But here, if it has a metal, it will be an ionic compound. If it has metal, it's an ionic compound. Say it with me one more time. If it has a metal, it's an ionic compound.